Hey, second period geometry. It is Mrs. Applegarth, and today we're going to be doing review for questions number 31 to 35 on our final. Welcome. The information you need for question number 31 is all about equations of lines. We've done a few, like none of this information is anything that we haven't seen before except for this points on a line part. So slope is rise over run. So it's how far up you go divided by how far over you go. To find the y-intercept, you put your pencil on the y and keep it there until you hit your line. Bing! And then whatever number you're on, that is your y-intercept. Points on the line, we are going to trade out the x and the y for those numbers, and it ends up making a true statement. So if they give you a point, well, we're going to take the y value, put it here, and then the x value and put it here. So let's see how that works for this problem here. It says, which of the following equations will pass through the points 1, 2, and 2, 6? So I included a little graph. If you guys need to graph these to find out the slope, use whatever tools you need. You're not going to be restricted when you take your final. So let's look at these points. So over 1, so this is our x and our y, and then it's our x and our y. So we always go over first. So we go over 1 and up 2. This is our first point. And then it's over 2, up 6. Oh, we got off the graph here. Okay. So we're going to find the slope. So we're going to count up how many rainbows and over how many rainbows. And so it's going to be 1, 2, 3, 4, and over 1. So you can see, oh, it has to be this guy right here. So, because this was the only one that has a slope of 4. All the other ones, this is -4, this is -2, and this is +2. But we're going to finish this up just to make sure we have the right one for surezies. So we know that our slope is 4 over 1. And then we're going to look at our y-intercept. Is it at -2? We go, okay, finger on the y. We look down. Oh, yep, there it is at -2. So it just confirms. And then let's put our numbers in just to make sure both numbers work for this. Does 2, so I'm going to put 2 in for the y and 1 in for the x. So does 2 equal 4 times 1 minus 2? 4 times 1 is 4, minus 2 is 2. So that one works. Let's just make sure the other one works as well. So I'm going to put 6 in for y. And then I'm going to put 2 in for the x. And then it's -2. Is 4 times 2 is 8. Is 8 minus 2 equal to 6? Heck yeah, it is. So 6 equals 6. So we can say with confidence that y equals 4x minus 2 is the equation that passes through both of these points. Because when I plug both of them in, it ends up being true. Okay, I'm going to erase this little stuff over here so I can do our next problem and you guys can see. So practice problem number 2. Which of the following equations will pass through the points -1, 3, and -2, 1? So let's go ahead and graph that, and let's see if we can find the slopes. If the slope is 2, we're going to have to test both of these ones, but if the slope is -5 or -2, then we can just select the one it is. Okay, so -1, 3 is here, and -2, 1 is here. So the slope, let's make the line. Let's just draw this line in here. Okay, so we have this nice little line here. Let's count the boxes to see how far up we go and how far over we go. So this is up 1, 2, and over 1. Okay, so we have a choice to make. It's either this one or this one because the slope is 2 for both of these, but at least we've now eliminated these two guys. Okay, we just have to determine, is the y-intercept -5 or +5? Let's look at here. So we put our finger on the y-axis and we don't, we put our pencil on the y-axis and we don't stop until we hit, boop, our line. So it's definitely going to be the +5 because -5 is down low. So +5 is this one, and we're going to plug in these 2 points just to make sure. So we're going to go for the y, we're going to put in 3. And for the x, we're going to put in -1. And make sure that when we do this math, we get the right answer. So -2 times 2 times -1 is -2. And when I add -2 plus 5, we get 3. So I get a true statement. Okay, so I'm going to do the same thing, but instead of using -1 and 3, I'm going to use -2 and 1. So where the y is, I'm going to make it 1. That's not the one I wanted. So where the y is, I'm going to put a +1. And where the x is, I'm going to put -2. And if this is a true statement, then I know that these 2 points are on my line. So 2 times -2 is -4. And -4 plus 5 is 1. So I get 2 true statements here. When I plug in this point into my equation, I get a true statement. When I plug this point into my equation, I also get a true statement. So that way I know that these 2 points are on this line. All right, that's your practice problems for here. Pause before you move on to the next question and get caught up. And then once everybody is ready, you guys can move on to the next question. All right, so for question number 32, you're going to need the slope formula, the equation of a line between the equation of the slope between 2 points. So it is y2 minus y1 over x2 minus x1. We also have to know that perpendicular lines have slopes that are negative or opposite, reciprocals, and their reciprocals are fractions. And remember, that just means we are flipping the slope. Okay, so let me show you this in practice problem number 1. Find the slope of a line perpendicular to the line passing through these 2 points. So the first thing we're going to do is I'm going to go in and I'm going to label x1, y1, and x2, y2. So x1, y1, and x2, y2, and then I'm going to put it into my formula. So where the y2 happens, I'm going to put in 1. Where the y1 happens, I'm going to put in the 3. So it's always going to be minus. So we're going to go minus 3. And that is going to be the top of my fraction. And on the bottom of my fraction, where the x2 is, I'm going to put in 0. So here my x2 was 0, so that goes in this bottom left corner. And then I'm going to put minus, and then whatever x1 is. So it's going to be 0 minus negative 4. I need both of these pieces because minus a negative is going to be positive. And if you don't know that, just put it in your calculator like this and it will be okay. So let's do the top in our calculator. Let me show you. So we get to go 1 minus 3 equals negative 2. So then we say and then 0 minus negative 4 equals 4. So now I have negative 2 over 4. So minus a negative ends up being positive. So the next thing I'm going to do is I'm going to flip it. If you can see that this reduces, you can also reduce it. It doesn't matter which order. You flipping and reducing, it doesn't matter which order. Okay, so now we're gonna flip the 4 and the 2, and we're gonna make this negative positive because we want the opposite reciprocal. Okay, and then 4 divided by 2 is 2, so the answer to this question is 2. Okay, let's do this a little bit faster motion. So we get, so again, we're going to label so that if we get distracted in the middle of this, we know who goes where. So we label and then we put into their proper place. So y2 is negative 3, he goes first, minus y1, which is negative 1. And then on the bottom, we have x2, which is negative 4, minus x1, which is negative 3. And then we just let our calculator do the talking here. So this is going to be negative 3 minus negative 1, which is negative 2. And then negative 4 minus negative 3, which is negative 1. A negative and a negative is positive. I'm going to simplify this down just so that when we do our action items on it. So now I need to flip it and take the opposite sign. This is going to be 1 over 2. Because this ended up being positive, the slope for the perpendicular is going to be negative. All right, you guys take a minute, see if you can do this problem. Go ahead and pause this recording, and once everybody is ready, go ahead and press play to reveal the answer. All right, check your answer. We go negative 2 minus 4 and negative 4 minus 4. We get negative 6 over negative 8. The negative and a negative make a positive, so we get positive 6 over 8. So we're going to flip those, so that's 8 over 6. And then because this one is positive, the perpendicular one is going to be negative. And actually 6 over 8 has a common factor of 2, so I'm going to divide both of them by 2 to get negative 4 over 3, so it reduces down 1. If you don't know how to reduce this, you can, there's a way you can do it using the fraction button on the calculator. The fraction button looks like this, A, B over C. You type in 8, hit the fraction button. On your screen, it's going to produce a little owl. and then punch in 6 and then hit enter, and it will reduce it down for you. So I don't, the reducing part I'm not super worried about because you have a calculator that can help you with that. And if you guys need more help with that, I can walk you through it when I get back. All right, when you guys are ready, when everybody has this down, go ahead and move on to the next problem. Triangle congruence we've talked about before. We have side angle side, side side side. Hypotenuse leg is for right triangles only. Hypotenuse is the longest side across from the 90 degrees, and a leg is any of the other sides. Angle side angle, and angle angle side. This is also on the above the TV. So if you get lost from this, it lives above the TV. Situations that we need to keep track of are vertical angles. Vertical angles are when two lines cross. It gives you two equal angles. A lot of times it'll look like a bow tie. Overlap or sharing a side gives you two equal sides. So this would be the angle in the side angle side, or angle side angle would be one of the angles in these scenarios. An overlapping or sharing side will give us two equal sides, which means in here it'll give you one of the sides. So if you can look at the givens and say, oh, I have two of those sides, and then it's overlapping or sharing a side, then that gives you that third side. A bisector will, if you bisect something, you will automatically make, so if it's bisecting an angle, it'll make equal angles. If it's bisecting a side, it'll make equal sides. All right, let's look at our practice problem here. This is what I meant by a bow tie. It says angle L is congruent to angle K, and R is the midpoint of LK. Triangle LRJ is congruent to triangle KRT by what? So step number one is, let's go ahead and mark all this stuff on our triangle so that we can determine which of these little buddies the scenario is presenting. So so we're going to mark angle L, and we mark our angles with a little rainbow. It's congruent to angle K, so those two match. R is a midpoint of LK. So it creates, a midpoint will create two congruent sides. It does say that this is a congruent triangle, so we're missing something. So let's go here. Vertical angles make a bow tie. So where the middle of the bow tie will have the congruent angles. So we put two little rainbows to look at our congruent angles, and we say, then let's take a walk around our triangle. So I'm not going to start here because I have no markings here. So I'm going to start where I have markings. So we go, okay, yeah, we put markings here. This is, and you go, is this a side or an angle? If it has a rainbow, it's an angle. If it has a tick mark, it's a side. So this is going to be angle, side, angle. So these triangles are congruent by angle, side, angle. All right, let's look at another scenario. I know it seems crazy, but we can do it. In this figure, JR is congruent to TR. So let's go ahead and mark that. Boop. And R is the midpoint of LK. So if R is in the middle, then LR is congruent to RK. Let's put another tick mark there. We'll put 2 to show that it's different from the first one we did. A midpoint will always make two equal sides. And then what can we say our triangles are congruent by? Which of these scenarios? So we go, okay, I have a bow tie. So a bow tie means I have vertical angles. So that means the angles in the middle of our bow tie are congruent. So then we take a walk around our triangle. I'm not going to start over here because I have no markings over here. So start at your first marking and go towards your next mark. So this is a side, and then I have an angle, and then I have a side. So these triangles are congruent by side, angle, side. All right. That's all the practice we're going to do on this one. Once everybody is caught up, go ahead, pause this video for now, make sure everybody's caught up, and once they are, go ahead and move on to the next problem. All right, question number 34 is talking about triangle inequalities. There is something about these little triangles that it's, once we talk about it, you'll go, oh, well, that makes sense. But we just don't talk about it in any kind of format. So we're going to talk about it now, and you guys are like, oh yeah, that totally makes sense. So if one side of a triangle, so let's take this one, JH, is longer than another side. Let's go angle, or this side, JI. So 8, we can all agree 8 is longer than 5. Then the angle opposite the longer side, so we look at 8, who is opposite of 8? Oh, it's this 94 right here. Has a greater measure than the angle opposite the shorter side. So I think of it like your, if you have two hands that are reaching, these are my little hands, and they're pulling on a string. If if your arms are opening wider, this string that holds these little hands, are holding that string, that gets longer. Then if you close it to a shorter distance, so if your hands are holding only from I to J, I don't know what this hand is trying to tell you guys, but so if my string is holding it from here, and I'm only opening it just this little much, then the string is going to be shorter. So I like to think of it in terms of your hands holding a string. So essentially is the wider the angle, the longer the side. And then this side is going to be across from a bigger angle than the angle that is across from the smaller side. So let me show you how it works. Going to be given a triangle. It's going to have angles in it. So this one is 15, 65, and 10. And it's going to say list the sides of the triangle from smallest to shortest. So we go smallest first. Sorry, smallest to longest. To largest. Okay, to name a side, you need 2 letters. So I'm going to go smallest side is going to be across from the smallest angle. So that's going to be BC. So BC is the smallest because he's across from the smallest angle. Then I'm going to find the next smallest angle, and that's angle B. He's 65. So the side across from angle B is AC. And I put the line over him. Okay. And then the last side, it's the largest. It's across from the largest angle. That is AB. So the smallest to largest is BC is the smallest, AC is the medium, and AB is the longest. And we know that because they are across from the smallest, medium, and largest angle. Okay? All right, practice problem number 2 says we have angle A is 20, angle B is 40, angle C is 120. List the sides from smallest to largest. So we're going to go smallest angle is across from the smallest side. It's going to be BC. Medium angle is across the medium side, that's AC. And largest side is across from the largest angle, that's AB. Okay, so from smallest to largest, it goes BC, AC, and AB. All right, a little bit different here. Angle A is 65, angle B is 55, and angle C is 60. So I'm going to find, we want from smallest to largest, I'm going to find the smallest angle. In that case here, it's B. Across from B is AC. Then I'm going to find the next biggest angle, that's the 60. That's 60 is across from AB. And then our largest angle is a 65. And please note, this is not drawn to scale. So if it's, never assume that a picture is drawn to scale, especially when they give you the angle measures and you're like, that's not looking like it's a bigger angle. Just be okay with that. Smallest to largest is based on the numbers versus what your eyeballs are telling you. All right, when everybody has this problem done, go ahead and move on to the next problem. Question number 35. But make sure we pause this video. Don't move on until everybody's ready. Okay, remote interior angles. We've met this little buddy before. So this is kind of a review. But remote interior angles says that the two angles on the inside of the triangle add up to equal this little outside angle here. So angle 1 and angle 2 is equal to angle 4. So an angle bisector creates two equal angles is the other piece of information we need. So an angle bisector creates two equal angles. All right, let's look at the scenario where we're going to use these two pieces. We have this figure here. We know that angle A is 55, angle C is 60, and then BD bisects ABE. So a bisector will create two equal angles. So what we're going to do is we're going to find the big exterior angle and divide by 2. So we're going to use this exterior angle theorem. So angle 1 is going to be 60, angle 2 is going to be 55. So we're going to go 60 plus 55. And 60 plus 55 is 115. So this whole angle over here is 115. So this whole thing is 115. And we look, they want us to find A, B, D. So they don't want the 115. They want half of that because it's bisected. So we're going to take the 115 and divide by 2. And 115 divided by 2 is 57.5. And we're not afraid of decimals because we have a calculator. Okay, so the process is add these angles together. Add these two interior angles together and then divide it by 2 to find the angle cut in half. Okie dokie, let's see if we can do that. We'll do a practice problem here. Okay, so we're going to add these two angles together. We got our 45 plus our 81. We're going to bring our calculator into this. 45 plus 81 So 126. And then we're going to take our 126 and divide by 2. Oh, it's 63, yay. Okay, so our answer is going to be 63 degrees. All right, go ahead and pause this video. Do practice problem number 3. And once everybody has it done, go ahead and press play and reveal this answer. All right, did you get 55 degrees? If you got 55 degrees, you are correct. You add 40 and 70, get 110, then divide that by 2 to get 55. All right, once everybody has this correct answer down, go ahead and move on to the next problem. If you are still waiting for people to write this down, go ahead and press pause, let people finish, and we'd be good to go. And actually, that's it. 35 is our last problem for this day. Thank you guys for joining us. If there's time left in the class, you guys can go ahead and do the Delta Math, but if not, go ahead and take that quiz, and best of luck. We'll see you on Monday.